Hi, friends, this video is about reinforced cement concrete. In this video we will learn about the reinforced cement concrete, advantages of reinforced cement concrete, and disadvantages of reinforced cement concrete. In this section, we will learn what is reinforced cement concrete and how does it work, or what everyone ought to know about reinforced cement concrete. Concrete is strong in compression and weak in tension. Plain cement concrete has very low tensile strength. To improve the tensile strength of concrete, some sort of reinforcement is needed which can take up the tensile stresses developed in the structure. A simply supported, plain concrete beam subjected to loads acting downward carries bending compressive stresses in the material above neutral axis and bending tensile stresses in the material below neutral axis as shown in figure. Since concrete is weak in tension, its load-carrying capacity is controlled by allowable stresses in tension, and it is seen that the load-carrying capacity is very small. In case steel bars are embedded in concrete close to the tension face as shown in figure, the beam becomes a reinforced concrete beam and its load-carrying capacity is very much increased. It becomes as high as about 20 times of that of the plain concrete beam. The original or existing strength of plain concrete beam is increased by additional tensile strength by using steel bars as reinforcement. Hence, in general, in reinforced concrete beams, the concrete resists the compressive force and longitudinal steel bars resist tensile force. The reinforcing steel is placed in the forms and fresh concrete is poured around it. This solidified composite mass is called as reinforced cement concrete and is abbreviated as RCC. Thus, reinforced cement concrete is a composite material which is made up of concrete and steel reinforcement. RCC is a versatile construction material which is strong in compression as well as tension. The use of reinforcement in concrete not only increases its strength but also helps in preventing the temperature and shrinkage stresses. The steel reinforcement, generally in the form of steel bars, are placed in the tensile zone of the structure and take up the tensile stresses. In the simply supported beams as shown in figure A2, the steel bars are placed near the bottom face, tension side, and in cantilever beams as shown in figure B2, the steel bars are placed near top face, tension side. The composite action of steel and concrete in a reinforced concrete section is dependent on the following important factors: I. The bond between steel and concrete. 2. Prevention of corrosion of steel bars embedded in the concrete. 3. Practically equal thermal expansion of both concrete and steel. Many different types of structures and components of structures can be built using reinforced concrete, including slabs, walls, beams, columns, foundations, frames and more. Uses of reinforced concrete. Reinforced cement concrete has innumerable uses in construction, some of which are listed below. 1. Buildings. 2. Flyovers. 3. Water tanks. 4. Road and rail bridges. 5. Chimneys and towers. 6. Retaining walls. 7. Bunkers and silos. This section is about advantages of reinforced cement concrete. Number 1 advantage is strength. RCC has very good strength in tension as well as compression. Number 2 advantage is durability. RCC structures are durable if designed and laid properly. They can last up to 100 years. Number 3 advantages is moldability. RCC sections can be given any shape easily by properly designing the formwork. Thus, it is more suitable for architectural requirements. Number 4 advantages. Ductility. The steel reinforcement imparts ductility to the RCC structures. 5 advantages is economy. RCC is cheaper as compared to steel and pre-stressed concrete. There is an overall economy by using RCC because its maintenance cost is low. 6 advantage is transportation. The raw materials which are required for RCC, i.e., cement, sand aggregate, water and steel, are easily available and can be transported easily. Nowadays ready-mix concrete, RMC, is used for faster and better construction. RMC is the concrete which is manufactured in the factory and transported to the site in green or plastic state. 7 advantage is fire resistance. RCC structures are more fire-resistant than other commonly used construction materials like steel and wood. No. 8. Advantages: permeability. RCC is almost impermeable to moisture. No. 9. Advantages: seismic resistance. Properly designed RCC structures are extremely resistant to earthquakes. Despite the earlier mentioned advantages, RCC has various disadvantages. This section 4 is about disadvantages of reinforced cement concrete. No. 1 is RCC structures are heavier than structures of other materials like steel, wood and glass, etc. No. 2. Disadvantages: needs lot of form works. RCC needs lot of form work, centering and shuttering to be fixed, thus require lot of site space and skilled labor. No. 3. Disadvantage is takes time to attain its full strength. Concrete takes time to attain its full strength. Thus, RCC structures can't be used immediately after construction unlike steel structures.